Hello everyone, we are Group 2, and this is our final project of the Principles of Remote Sensing class. So to answer the question 1, define the study region of the Taipei city. The method that we used was using the slope and mountain area to define our study region with QGIS and GEE. And how we define the mountain and slope area was that we found the data on the open data site provided by the government to get the precise location of the legal mountain area and slope area of the Taipei city. And after we had the shapefile of it, we added into the QGIS and cut the non-mountain and slope area of the Taipei city and had this. So this is the area in Taipei without the legal mountain and slope area. But that's not it. We also took a look into the definition of mountains from the Taiwan's law, and we add the condition of the slope being under 5% and add the condition into the GEE. Therefore, came up with this picture, this GEE version of so this picture came out of two reasons. The first reason is the open data from the provided from the government. The second is the adding the condition of below 5% percentage of slope. So this is how we define the study region. Okay, to answer the question 2, does the city get greener or not? The way for us to answer this question is by using the average EVI and observing the ups and downs of the EVI to came up with the conclusion that yes, the city did get greener from 1986, and the change is multi-directional, which means the trend goes up and goes down. It doesn't have a fixed trend. The reason for us to not use SAFI and NDVI was that in our specific region, if we use SAFI and NDVI, we would get a corrupted data. But to our observation, we found out that even though we cannot show it on the graph, the trend, the ups and downs were almost identical. They just have different ups and downs, but the overall trend is the same. So we feel confident that using the average EVI can show the true nature of the city getting greener or not. So to answer question 3, the greening up area and the greening down area in Taipei city. The method that we used to find the answer was we used the supervised training, the Persuado one, to track the NDVI change from 1987 to 2021 in order to find the obvious greening up and greening down areas. The yellow part in the picture on the right is the building, and the green part is vegetation, and the blue part is water and background. We cut it out and put them into the same category because they are not what we wanted to see. After observing the NDVI change, we also pulled out 34 pictures of every year and to observe the NDVI change. And the 34 picture, we merged it into a GIF, and this is the picture that you're seeing on the right, which is constantly changing because it's a GIF. So through the previous picture, we located Da'an Forest Park as the greening up location, but we have to say it up front that there are multiple greening up regions. according to our observation. So we're only choosing Da for Spark because the ratio that it goes up and goes down is very significant. And according to the chart, you can see that there is a significant growth from the 1985 to the 1995 time period, and that reason is that government started tearing down old buildings and started constructing parks. So that is a reason for there to be a spike. And from the 2000s to 2020, we can see we can see the EVI gradually growing because there are more and more constructing company building there and advertising that place as a place of nature, a place with fireflies. So we assume that they are trying to make it greener, trying to make it more natural, trying to make that place a place with more vegetation, so they can sell their apartments or houses better. As for the greening down area, we used QGIS to cut out to digitalize the Taipei Arena. Be aware, this is the Taipei Arena, not the not the big dome. This is the Taipei Arena, and as you can see in the chart, it had a sharp drop since the 1990s, and it has stayed almost static, which is not a lot of big changes from the 1998 and 1997. It stayed between 0 and 0.25, the average EVI by year. And the reason for that is, according to our research, we found out that the Taipei Arena was a baseball field with no roof before the Taipei Arena started constructing. And after the Taipei Arena started constructing, because it is a arena with a roof, so from the point of view of the satellite, it had less vegetation. So that is the reason that we think can represent and can show the influence of the EVI drop. It's because the Taipei Arena had a roof and the previous baseball field doesn't, so it had more EVI before. So this is our final project. Thank you for listening, and we hope you have a wonderful day.